In this section, we're going to learn about the Pythagorean theorem and how the Pythagorean theorem can help us find the missing side of a right triangle. In order to do that, first we're going to understand and identify the parts of a right triangle, and then we're going to learn about what the Pythagorean theorem is and how it can help us find the missing side of a right triangle. So first, let's talk about a right triangle. So a triangle, of course, is going to have 3 sides and 3 angles. Now, in order to be a right triangle, one of those angles would have to be a right angle. Within a right triangle, we have sides called the legs, and there are 2 of those, and those are the sides that form the right angle. We're going to label those sides A and B. Then we also have a hypotenuse, which is the side that is opposite the right angle. It's also going to be the longest side of our right triangle, and we're going to label that side C. So on example 1, if I find my legs, I'm looking for the 2 sides that form my right angle. That would be these 2 green sides here. And so I'm going to label these 2 sides A and B. Now it's also possible to flip-flop them and call this side A and this side B. That wouldn't matter. Next, I'm going to look for my hypotenuse, which is always going to be located across from my right angle. And that I'm going to label side C. So on this triangle here, pause the video, label the legs A and B, and label the hypotenuse side C. Remember, the legs are the sides that form the right angle, and the hypotenuse is the side that's across from the right angle. Press play when you're ready to check your answer. So in this example, here's my right angle. These 2 green sides are the sides that are forming the right angle, therefore these are sides A and B. I could call this A and this B also. Those are my legs. My hypotenuse is the side that is located across from the right angle, and that's going to be my hypotenuse or side C. So the Pythagorean theorem is a special formula that only applies to right triangles. And what the Pythagorean theorem says is if we take the length of one leg and square it, and add it to the length of the other leg and square it, it would equal the length of the hypotenuse squared. So what we're going to be using for our formula, instead of words, is the algebraic formula, which is a squared plus b squared, because remember a and b are the lengths of our legs, so a squared plus b squared equals c squared. This will always be the formula, it will never change. This is something you're probably going to remember for a really long time. It's just one of those commonly known formulas, but our goal is to learn how to use it. Before we do that, let's get used to graphing the coordinate plane, because the Pythagorean theorem can eventually be used to help us find distances in the coordinate plane. So first, we're going to graph each set of points below, and we're going to connect them to form a right triangle, and we're going to label our points A, B, and C. Then we're going to count and find the length of each leg. So first, let's label point A. So point A would be over 1 up 4, because that's my x and my y. Point B is 5, 1, so I'm going to go over 5 and up 1. And point C is 1, 1, so I'm going to go over 1 and up 1. Now let's not confuse this A, B, and C with the A, B, and C in the Pythagorean theorem. There's actually a big difference. Notice that these are lowercase letters and these are uppercase letters. So now I'm going to connect these points to form a right triangle. Now the reason I know it's a right triangle is because this line segment here, AC, is a vertical line segment, and this line segment here, CB, is a horizontal line segment. And so vertical line segments and horizontal line segments form a right angle. Now in this, the length of my legs would be the side lengths that are forming that right angle. And so that would be segment AC and CB. And so I can count these distances. And so let's say this is leg 1. That would be 1, 2, 3, 4 units long. And my other leg would be segment AC. And so this would be 1, 2, 3 units long. Now if you accidentally flip-flop them and say leg 1 is 3 and leg 2 is 4, that's okay. Now eventually what we're going to be doing with this is we're going to be using the Pythagorean theorem to find the distance from A to B, since in the coordinate plane we can't count diagonally. We can only count vertically and horizontally. But we'll be doing that tomorrow. So at this point, what I'd like you to do is to plot points A, B, and C in this coordinate plane. Connect your points to form a right angle, and then find the length of each leg and label it here. Pause the video, press play when you're ready to check your answer. So when I plotted point A, I went to the left 6 spaces and up 0. For point B, I went to the right 2 spaces and up 6, and for point C, I went to the right 2 and up 0. When I connected these points, I got my right triangle with my right angle being here, because that's where my vertical segment and my horizontal segment meet. The length, that means my legs, are the segments BC and AC, and so BC was 1, 2, 3, 4, 5, 6 units long, and AC was 1, 2, 3, 4, 5, 6, 7, 8 units long. Now eventually we're going to be able to use our formula to find the length from segment AB. So here's where we're going to apply the Pythagorean theorem to finding the missing side of a right triangle. So on example 3, I noticed that I have my 2 legs. I have the sides that are forming the right angle. What I don't have in this case is my hypotenuse. So my unknown here is going to be C. So to do this, the very first thing I'm going to do, and I do this every time I do a Pythagorean theorem problem, is I write down my formula. A squared plus B squared equals C squared. Next is to substitute in my information. So I can see that A can be substituted with 4. Remember, when I substitute, I use parentheses. B can be substituted with 3. And I don't know C, so I can't replace that with anything. So now I'm going to solve this equation by first simplifying. So 4 times 4 would be 16, plus 3 times 3 would be 9. All of that will equal C squared. And then 16 plus 9 is 25, which equals C squared. Now my last step to get C by itself, since C is being squared, the inverse of something being squared is the square root. And so what I'm trying to find here is all of the possible values of C, because the inverse or the square root of C squared is C. So any values that C could be, so that way when I square it would give me 25. And so if you're thinking that the answer is 5, you would definitely be accurate, because 5 times itself equals 25. Now it's important to note that there's actually one other number that C could be that would also give us 25 if you were to multiply it by its exact self. And that number would be negative 5, because negative 5 times its exact self of negative 5, 5 times 5 is 25, and negative times negative is positive. So in fact, 25 has 2 square roots. It has a positive version and a negative version. Now in this case, since we're talking about a distance, we're not going to include the negative version in our answer, and we're only going to focus on the positive version. And so that means that in this case, the missing length would be 5 inches. And the Pythagorean theorem is how I've gotten that. Let's try example 4. So on example 4, again, I've got my 2 legs. I've got the 2 sides that are forming the right angle. So I've got my A and my B. And what I'm missing is my hypotenuse. So my unknown value is going to be C. So just like I started the previous problem, I'm going to start by writing down the Pythagorean theorem. A squared plus B squared equals C squared. I'm going to substitute in my numbers. It doesn't really matter where the legs go. In the previous example, it had actually said that A was 4 and B was 3. Here it doesn't say that, but they're interchangeable. So I could do 12 squared plus 5 squared, or I could do 5 squared plus 12 squared. It won't matter because after I square these numbers, I'm adding, and adding is commutative. So 12 squared needs to do 12 times itself, which would get me 144. 5 times 5 is 25, equals C squared. 144 plus 25 is 169, equals C squared. And then to get C by itself, I would square root both sides. So right now what I'm looking for is a number times itself that would give me 169. And certainly if you didn't know that, you could use your calculator. And what you would end up with is 13. Now don't forget, and I could prove that by doing 13 times 13 is 169. Don't forget that it could also be negative 13, because negative 13 times negative 13 is also 169. But we're going to ignore that answer because we're talking about a distance, and a distance must be positive. And so in this case, my missing side is 13 centimeters. The next 2 examples are just applying some real-world context of how you might see the Pythagorean theorem used in the real world. In this case, we've got a ladder that's leaning up against a wall. And so you can see here's my wall. This would be my floor, which would be my right angle. And so I've got a right triangle that is formed by the wall, the floor, and the length of the ladder. And so in this case, we're trying to find the hypotenuse of this right triangle that is formed. And so to do that, we're going to use our Pythagorean theorem. So just to get you started, I'm going to start by writing down my formula. A squared plus b squared equals c squared. So go ahead and try to complete this example on your own by finding the missing hypotenuse. Be sure to replace your legs into the formula and solve like we did above. Press play when you're ready to check your answer. So my legs in this case are the sides that are forming the right angle, which are the floor and the wall. So I can replace a with 8, b with 6. A squared is 64, 8 squared is 64, 6 squared is 36. All of this would equal c squared. 64 plus 36 is 100. And then to get c squared by itself, I do the inverse, which is to square root. That means I'm looking for the number times itself. That would give me 100. That could be 10 or negative 10. But again, it's a distance, so I'm only going to use positive, and so my answer would be 10 feet. Give word problem 2 a try. Read through the problem, do what it asks, find the missing distance, press play when you're ready to check your answer. So in this example, we have 4 people standing in a rectangle playing frisbee. We're going to draw the line showing the path of the frisbee if person A throws to person C. And so that's this dashed line segment right here. By drawing that in, we can see that we've created this right triangle because since we're told that we're standing in a rectangle, we're allowed to assume that all of these corners would be right angles because that's true in rectangles. And so that means that in this triangle right here, I've got a right angle, which means it's a right triangle. Since it's a right triangle, I can use the Pythagorean theorem to find the missing distance of the hypotenuse. And I've got my 2 legs of 30 feet and 40 feet. So those would take the place of A and B in my Pythagorean theorem. Again, it's really important to start by writing down your formula. 30 squared means to do 30 times 30, which would be 900. 40 squared is 40 times 40, which would be 1600. And if I add these 2 numbers together, I've got 2500. Notice the work is being done in the vertical format, and I'm keeping c squared on the right side of my equal sign the whole time. If c squared equals 2500, I'm going to square root both sides to get c by itself, and I'm searching for the number times its exact self. That would give me 2500. I wouldn't expect you to know that. Feel free to use a calculator, and that number would be 50. Remember, it could also be negative 50, because negative 50 times negative 50 would also be 2500, but since it's a distance, we're only talking about the positive answer.